Yeah, so my talk is sweating the small stuff, recreating subtle design details using Sass. And I was going to have a longer title, but it wouldn't fit. So, but my name is Tim Hettler. I'm an open standards developer at RGA in New York City. And so for the next 20 minutes, I'm going to be talking about this button and the process that it took from going from Photoshop comp to something that is in production today. So when we were doing a redesign for a client last year, we were kind of embraced progressive enhancement, CSS3, and we're like, we're not going to cut up sprites anymore. We're going to do this with CSS. And so this is what our designers created in Photoshop. We have a normal state and an active state. And it looks like a pretty straightforward conversion. You know, there's rounded corners, gradient overlays, text shadows, drop shadows. It should be something easy to convert to CSS. So the designers just kind of gave the developers the Photoshop file, and they're like, all right, go to town. And so this is what our developers came back with. And this is not exactly what we're looking for. So obviously the colors are all wrong, the drop shadows are weird, and they're like, I don't know, we just looked at the Photoshop file and we just put everything in. And so we started talking with the designers and the developers about like what the problem was. And so we realized in some cases what the designers use to describe something is different than what the developers need. And in other cases, the designers have vocabulary that the developers just don't have at all. So you know, we have a failure to communicate here. Designers and developers aren't speaking the same language. What the designers put into Photoshop isn't what developers need for CSS. So how do we solve this translation issue? Well, the traditional approach was to create, you know, a style guide like this. And this is comically complex and large. You're not supposed to be able to read what it is. But this is actually what our designers had to produce for us because they stopped trusting us, basically, to take our Photoshop files and make it in the CSS without screwing it up. So this is like, we have so many different color buttons. It's an e-commerce site that we're working for. So it was like all these different buttons, and then we had to define the top gradient, the bottom gradient for all the states. And also, and there's a second level of complexity because some of the buttons needed white text and some of the buttons needed dark text for contrast reasons. So we have this really kind of complex style guide. And there's a lot of failure points with this traditional translation process. I mean, the designers have to translate their own designs, and then the developers have to take that file and then translate it back into CSS. And so wouldn't it be great if we could cut out the middleman and we could automate this translation? Well, of course we can, otherwise my talk would be really short. And so we can automate this translation with preprocessors. They can act as the Rosetta Stone between designers and developers, and we can use them to translate our designs from Photoshop to CSS flawlessly. And so let's go back and try to rebuild this button using Sass and ConfUS. Just a note about the technologies. All my examples are in Sass, but if you use less or stylus, you can definitely use the same ideas. And if you haven't used a preprocessor yet, your mind is about to explode because they're amazing. And so I'm also using ConfUS, which is a framework that's built on top of Sass, which adds a bunch of mix-ins and functions to solve a lot of common problems that we have as developers. And ConfUS kind of, it feels like the jelly that goes with Sass peanut butter. And so I don't use them separately at all anymore. It's always Sass and ConfUS. So first, before we get into like our translation, we have to like build up our base, and we have to sort of build all the stuff that isn't going to change about our button, regardless of the color and the context. And so we start off with like a prototype placeholder button, placeholder selector. And this is all the stuff that's just going to undo what browsers do by default to buttons, and kind of add all the stuff that isn't going to change, like our font and our border radius, stuff like that. And so now when we write our Sass, we can extend that button placeholder. And so we can work in sort of an object-oriented modular approach in our Sass. And then when it gets output to CSS, it's done in a performant way. So you can see here, instead of copying those 16 or so properties, we actually just increase the selector chain. And so this is one of the more powerful things with preprocessors, because you can, the way that you write the source code isn't necessarily how it gets compiled. So you can write in a way that is comfortable for you and like makes sense from maintenance perspective, but then when it gets compiled, it does what it needs to do to have the smallest file size. And so now we have our base, what we extend the button placeholder, and then we just add the unique things about that button. So the only thing that's different is the background color here, and we're already running into a problem here because as I said before, we want our dark buttons to have light text and our light buttons to have dark text. So let's see how we can use Sass to automate that translation process so that individual developers can't screw it up, basically. So we can use a built-in Sass function to compare color lightness. There's a function called lightness that returns a value between 0 and 100, just based on like the HSL value of that color. And so here we just do some simple logic, and we're saying if the color is greater than 50, so if the background color is a light color, we want to return dark text, and vice versa. So now our text color gets set programmatically. Instead of setting that color explicitly, we call a function and give it the background color, and then so you see on the right here when our CSS gets compiled, that decision gets made for us, and we don't have to worry about like if an individual developer is going to read our style guide properly or not. So Sass allows us to abstract design logic, and this is a really powerful tool because we can abstract this stuff. So these decisions happen behind the scenes, and so also later on, if like our marketing department comes and they're like, it really should be like 444, not 333. That A/B tests better. We can change that in one place, and then when we recompile, all these changes get made automatically. So now that we have our base and some simple design logic, let's talk about how to translate two commonly used layer styles from Photoshop and how to convert them to CSS. We're going to start with DropShadow and how to turn that into a CSS box shadow. And so this is a CSS conference, so I assume you've all written a box shadow before, but just to make sure we're all on the same page. The CSS syntax, we have X and Y offset, the blur radius, the spread radius, and then a color. And so this is what Photoshop gives us, which is pretty similar, but there's some important differences. Color and opacity is straightforward, and spread and size are pretty close to what we need. But the big difference here and what we're going to talk about is angle and distance. And so Photoshop it uses angle and distance to set the size of our shadow instead of just a straight up X and Y offset. And so you might not know right now, but at some point your like 15-year-old self knew how to do this. And so basically we have an angle and a distance, so we have a right triangle. And so to convert this from Photoshop to CSS, we need to find missing sides of a triangle. So good old SOHCAHTOA comes to play here. When I was building these slides, I was going to make a joke about the only thing I remember from trigonometry is SOHCAHTOA, but then that actually ended up being exactly what I needed, and so I didn't even realize it until I was like, wait, okay, yeah. So anyway, our X offset is our adjacent side of the triangle, and our Y offset is the opposite side, and so I don't remember too much about trigonometry, but so. These basic formulas come into play where it's just cosine of the angle times the distance for the X offset, and the sine of the angle times the distance for the Y offset. We can create a function that takes all of the values that are in the Photoshop layer style and does all these conversions automatically, and then returns a list of values that turns into a valid CSS syntax. And so this has actually been bundled as a Compass extension that you can download on GitHub. I was working on it myself, but then I was doing some research for this talk, and somebody had already pretty much done the exact same thing I had. So I'm linking to their stuff, because why reinvent the wheel? So now let's add the BoxShadow R button. We can take these values and put them right into our Sass code using these functions, and then when it gets compiled into CSS, we have a valid box shadow. So now our button has a nice subtle drop shadow in the normal state and then an inset drop shadow in the active state. And so now we have confidence that this drop shadow is exactly what our designer intended because we're using the same values that they put into Photoshop. And so we'll go over TextShadow because this is kind of a freebie one. All the math is the same for TextShadow, obviously. But the only difference between TextShadow and BoxShadow is that in CSS, the spread radius is not used by TextShadow for some. Actually, I don't know why, but it's just not there. So, so this function takes the Photoshop, takes the list that we return for this BoxShadow, and it just breaks up that list. Sass can manipulate lists kind of like arrays. So we're returning just the values that we're omitting the fourth value, which is the spread radius, so that it returns a valid TextShadow value. And so again, we're going to add this to our button. We're going to put in the values directly from Photoshop, and then when we get then what gets output is a valid TextShadow. So now we have a TextShadow that alternates. When we click on it, it just goes from top to bottom, so giving the illusion of depth. So, so we have our shadows, and now let's talk about how to convert a gradient overlay to linear gradient. And so this is a little more complex. This is the hard mode of the talk. But so again, you guys have all probably written a linear gradient before, but to make sure we're on the same page, we start with an angular keyword, which is the direction of the gradient, and then a series of color stops. And so Photoshop, what they give us is color and opacity, which again is straightforward stuff, and then our gradient, which can be a simple two-color fade, or it can be something crazy like many, many stops. Then we have the angle, which is the direction, and then the scale, which is the size of the gradient. Photoshop allows you to create gradient overlays that are larger or smaller than the containing element. And so angle, you'd think at first maybe is pretty straightforward. We might be able to just actually put in that value in the CSS, but surprise, there are some browser inconsistencies here. The vendor prefixed version of linear gradient, 0 degree points to east, but in the unprefixed version, 0 degree equals north. And in Photoshop, actually the vendor prefix is the same as the Photoshop version. So we have a lot of inconsistencies of what 0 degrees actually, where that actually points. And so how I've gone around this is I created a function that converts the angle to a keyword when possible. So if the angle is like in a cardinal or ordinal distance, like 0, 45, 90 degrees, it'll convert it to a keyword. But otherwise, it assumes that you want the unprefixed version of the angle, and so it subtracts 90 degrees from it. So this, most of the time, whenever I've worked with a designer, it's, they're working from like top or left or bottom. So this has never been a problem in real life before. But there is some limitations to what this conversion can do. But then, so let's move on to scale. Scale is a little more complex because we want it to grow and shrink. And so at first you might be like, well, we'll just use the background size property. But really we want to write this as a function, and functions only return one value. We can't return two different properties. But the way around this is to actually to manipulate our color stops and like where they are. And so in CSS, you're actually allowed to have stops that are less than 0% or greater than 100%. So if we wanted to scale something to this gradient to 150%, say, we still want the middle to be in the middle of our element. So we'd actually start at negative 25% and go to 125%. And I worked out this formula myself because I couldn't find it by Googling, and this actually ended up being the hardest part of this talk, is working out this formula. So I'm really proud of it. So now we need to take all of our color stops and we need to manipulate them based on our scale. And the way we do that with Sass is we're going to put our gradient colors and our gradient stops into two different lists, and then we're going to use a for loop. Just like any other programming language. And we're going to go through all those colors, and we're going to manipulate that stop based on the scale. And so we're going to sort of break those apart and then rebuild a new list that is what CSS needs to create a linear gradient. So this works for simple gradients, like a simple black to white fade. Or if your designer is on LSD and wants to do something super psychedelic, you can put it in many color stops. You can mess with the direction and the scale, and no matter how complex of a gradient you have in Photoshop, it'll convert to CSS perfectly. And so now, let's do the same thing we've done with all the other stuff. We're going to add the linear gradient to our button. We're going to put in the values that our designer wanted, and then when it converts to CSS, plot twist, something went wrong. And so the gradient looks right. It goes from dark to light, but the color values are incorrect. And so there's been a piece of our Photoshop layer styles that we've been ignoring this whole time, blend modes. And so let's talk about blend modes real quick. Blend modes are, they're a way to combine two different colors, a background and a foreground color together, using different mathematical functions. And so when I was kind of working out, trying to figure out a way to programmatically solve these problems that didn't have to rely on just style guides, when I was reading about blend modes, they're like, oh, it's all just math functions. The light bulb went off in my head, and I was like, oh, well, if they're just math functions, then we can create this in Sass. We can recreate all these things. So these are 3 examples of common blend modes. The first one is normal, which is like no blend mode, actually. So it just returns the foreground color, so what you put in is what you get. But the second one is our multiply blend mode, which is a darkening blend mode. And this combines the 2 colors together to create kind of a nice, like a dark, rusty, sort of a darker color, basically. And so finally, but what our designers wanted us to use is the overlay blend mode, which is a contrast blend mode. So the light colors get lighter and the dark colors get darker. It's actually a pretty sexy blend mode. I think overlay is one of the best. But so there are a few limitations with these blend mode functions. You have to know the foreground color and the background color ahead of time. In Photoshop, all that stuff is sort of done on the fly. So for like drop shadows and stuff like that, blend modes might not be a good choice because they're outside of the element, and so you don't necessarily know what the background color is going to be. But for gradient overlays, we know what our base background color is, and we know the gradient that we want to put in front of it, so blend modes work perfectly there. So let's update our gradient overlay conversion. And so this time, we're going to loop through all the colors, but instead of just returning that color, what we're going to do is we're going to blend it with our background color first, and then we're going to return that blended color. And so this has been I turned this into a Compass extension too, so if you want to use this, you can go on my GitHub account and check it out. But so let's put that into our project now, and when we use those blend modes and we compile our CSS, our button looks perfect. So now we've created a toolkit that allows us to translate our designs from Photoshop to CSS flawlessly with 100% confidence. And so we used to have a problem where every time a button got created on the site, we'd have to go through and do visual QA, and there were so many times where it was just like, well, the drop shadow isn't right. But now with Sass and with these functions, we can just have confidence that everything's going to work perfectly. And so no project is complete without a little bit of refactoring. So let's go and see how we can make things work a little bit better. There's a lot of redundancy here. There's a lot of, the background color is repeated a bunch of times. And if we wanted to make a new button, we'd have to copy all of this. But a better way to do it would be to take all that code and put it into a mixin that takes a background color as a parameter. And so now we can style a button with 1 line of code. And creating new buttons, stuff that buttons and colors that we didn't think of originally is easy. And all of our design logic is always followed, and we can be confident that everything works perfectly, which I think is pretty badass. So this kind of shows the power of Sass and the way that once you start using preprocessors, how you can start thinking about CSS differently and how you can think about designing your site. I think with preprocessors, we should start relying less on style guides, and designers and developers should be working together to build reusable systems to translate their designs flawlessly. It means we can work faster, and we can also be more confident that our subtle design details are going to translate perfectly. Thanks, guys.